Hi everybody, I am Brandy Herrera and today Alejandro Guillén, Diego Cordero, Luis Vega and me are going to talk about just a little bit of types of kernel. First, I would like to say that I'm sick at the moment of this presentation, so I can breathe very well. And sorry if I say something bad or you can hear my breath. So I hope that you like this presentation. Okay, what is a kernel? A kernel is the core component of operating system that acts as a bridge between software application and the hardware of a computer system. For example, it manages systems resources like CPU, memory, input and output devices, handles essential tasks such as file system management, management, sorry, and management. And for example, um, the kernel provides an abstraction layer that allows software applications to interact with the hardware without needing to understand its specific detail, enabling the smooth operation and coordination of all system components. Okay, there are mainly three types of kernels. First, we have a monolithic kernel, micro kernel, and hybrid kernel. What is monolithic kernel? Well, here all features a persistent function like such as process management, memory management, file system handling, and device driver operation are performed within the kernel space. Examples include traditional version of Unix and Linux kernel. Okay, second we have Microsoft microkernel. Sorry, what is okay? Microkernel architecture aims to keep the kernel as small as possible, legating most operating system device user space program known as servers. These servers include three kinds: a network stack, a file system, and device driver. And some examples are Minix and QNX. And finally, but not least, we have a hybrid kernel. What is? Okay, it's a combination of both, right? We have, remember, monolithic and micro kernel designs. They might keep some key services, and while delegating others to user space. And we can say that Windows NT Okay, we can say that Windows NT is an example of a hybrid kernel, where part portion of the operating system functionality runs in a kernel mode, while other components run in user.
Okay, I will now be explaining these key implementations of kernels. We have three types, right? We have the monolithic kernels, the microkernels, and the hybrid kernels. Um, when I say monolithic kernels, I'm referring to, for example, the Linux kernel that it was developed primarily by Linus Torvalds and a global community. And this Linux kernel follows a monolithic architecture that incorporates most system services and device drivers directly. Um, and is used in server operating systems like Ubuntu Server and Red Hat Enterprise Linux, as well as mobile devices, Android mobile devices. Then we have the microkernels. That an example of this is the Minix, that it was developed by Andrew Tannenbaum, and it emphasizes modularity and by separating the core functions like scheduling and the inter-process communications from higher level services, right? And we also have the QNX, for example. And now the hybrid kernel, it combines both uh, by taking, for example, the XNU, the Mac OS. It combines the Mac microkernel for multitasking and memory management with the BSD subsystems for networking and file management. And some examples are, yeah, the Powers Mac OS and the iOS devices that provides a balance between modularity and performance. Now, talking about emerging technologies and the future of kernels, we have the unikernels that are specialized single purpose kernels tailored for specific applications, reducing attack surfaces and improving efficiency. Some examples of these are the Mirage OS and the OSV. Um, by talking about real-time systems, I'm referring to, yeah, the real-time kernels that prioritize predictable timing, reducing latency for time-critical applications in automation and autonomous vehicles, mostly. Also in telecommunications. Some examples of these are the Preempt RT and the VxWorks. Now, the security enhancements that, for example, with this rise of also a sophisticated attacks, kernel security includes secure boot, signed kernel models, and memory protection to mitigate vulnerabilities. Some examples of these are the Linux kernels, um, and the Windows Secure Boot.
Now, I will tell you about the kernels in modern operating systems. To start with, we have the Linux kernel. It's a monolithic and open source kernel. It is optimizable to a wide range of devices and architectures. Some of use case are the operating system for servers, desktops, and mobile devices like Android or Chrome OS, as well as routers, switches, or other network devices. Other example is a Windows NT kernel. It's a monolithic kernel too. This kernel has a particular focus on security. It's made for desktops, operating systems, and Windows Server systems. Was made for Windows software, and some disadvantage are the lack of customization and is less transparency with control for users. And finally, we have the case of Mac OS X. This is a BSD based kernel combining elements of monolithic and microkernels. Kernels. It is developed by Apple for Mac OS operating system, and it's made focus on performance and integration with Apple hardware. Its main advantage is the stability and performance optimized for Apple hardware. His customization is much lower compared to Linux, for example. The kernel maintenance is a crucial process to ensure the proper functioning, security, and stability of the operating systems. This process involves various tasks, among which are the application of bug fixes. For this, the kernel developers constantly publish updates that correct the discovered bugs. Then we have the driver updates, and this to ensure compatibility and optimal hardware performance. And it's also important to update the operating system of security patches and release to fix specific vulnerabilities.
Kernel evolutions. Early operating systems. In the 1950s and 60s, IBM's big computers had simple kernels to do basic jobs like remembering things and running programs. Uh, Unix and Linux. In the 1970s, Unix was a big deal. It had a kernel right in assembly and it did cool things like letting lots of things happen at once and letting many people use it. BSD and Linux. In the 1980s, other versions of Unix like BSD made it better. In 1991, a person named Linus Torvalds made Linux. It was like Unix but different. It became very popular. monolithic kernel. Until the 1990s, most kernels were big blocks of the code that did everything. Microkernel. In the 80s and 90s, some kernels were smaller. They put some jobs outside the main part. They were smart but not so popular. Developers and modern advance. At the time when on big kernels like Linux got better. They worked on more kinds of computers and got faster and faster. Optimization on specialization. Recently, they made kernels better for special jobs like small computers and things that are always on the internet. Now we have kernel performance and kernel security. In kernel performance have a code optimizations. Developer works on optimizing the kernel code, improving its efficiency, and reproducing execution times. Resource management. The kernel efficiently management the system resource such as memory and processor. Concurrency handling. Mechanisms are implemented to ensure that the kernel can handle multiple tasks concurrently with compilation systems stability and kernel security. Access control. The kernel implements strict access control to protect itself from unauthorized access and ensure that only authorized process can access system resources. Process isolation. Virtualization and isolation techniques are used to prevent a compromised process from affecting other processes or the kernel itself. Intrusion detection. Intrusion detection mechanisms are implemented to identify and respond to attempts to attack the kernel and the operation system.
And that's it. Thank you so much for your attention.